Workability of concrete and factors affecting workability of concrete. Workability of concrete is a wide topic that is discussed in the civil engineering. Road Research Laboratory in UK defined workability as the property of concrete which determines the amount of useful internal work necessary to produce full compaction. If full compaction is not done in concrete, it leaves behind voids which can cause reduction in the strength of concrete. Another definition of workability of concrete is the ease with which the concrete can be compacted 100%, having regard to mode of compaction and place of deposition. Workable concrete shows very less internal friction between particles and overcomes the frictional resistance with just the amount of compacting effort provided. What is consistency? Consistency is another term that is used for workability. The terminology consistency is often loosely used for workability. Consistency is a general term to indicate fluidity or degree of fluidity of concrete, or it can also be said to indicate the degree of wetness of concrete. Consistency is the ability of a concrete to flow. A concrete which has high consistency may not be of right workability for a particular job. That is, a particular consistency may be used in mass concreting but may not be used for heavily reinforced structures. The factors that affect the workability of concrete. There are various factors that affect the workability of concrete: water content, size of aggregates, mixed proportions. These are some factors. Water content. Increasing the water content can help improve the workability of concrete. When we increase the water content, it increases the fluidity of the concrete. That is, the consistency increases, so the workability also increases. The practice of adding water is one of the easiest corrective measures that can be taken at the site. However, when you add water into the concrete, it helps improve the workability, but it will decrease the strength of the concrete. For this purpose, we add more cement into the concrete so that the water cement ratio remains constant. Next is size of aggregate. The bigger the size of aggregate, the less is the surface area, and hence less amount of water is required for lubricating the surface to reduce the friction. Thus, the concrete having large size aggregate is more workable for given quantity of water and paste. You see, as the size of the aggregate increases, the cement paste that is required to make this aggregate or this concrete workable decreases. If less size of aggregates are available, the requirement of cement paste will increase and the cement and the concrete will be less workable. Mix proportions. Aggregate and cement ratio is a measure of how lean or rich the concrete is. Lean means harsh, how harsh the concrete is. If aggregate cement ratio is higher, the concrete becomes leaner or harsher. In lean concrete, less paste is available for lubrication of aggregate, while in rich concrete, low aggregate cement ratio means more paste is available and which makes the concrete more workable. See there, these aggregates have less paste available around them which makes them less workable. If more paste is available around the concrete, they will be more workable. Size of aggregate, shape of aggregates. Angular, elongated or flaky aggregates makes concrete very harsh when compared to rounded aggregates. Rounded aggregates have considerably less surface area and less voids in comparison to angular or flaky aggregates. When less voids are available, the more paste will be available for lubrication. Being round in shape, the frictional resistance is greatly reduced. Here, these are the rounded aggregates and these are the angular aggregates. The angular aggregates have more surface area and more voids which require more cement paste, whereas the rounded aggregates have lesser voids and lesser surface area, thus it requires less cement paste for lubrication of concrete. Surface texture of aggregate. The aggregates that have smooth or glossy texture have less surface area compared to rough texture aggregates. If an aggregate is smooth, it will be more workable. However, the strength reduces. This provides better workability as less amount of water is required for lubricating effect. But taking into account the poor interlocking action provided by the smooth aggregates, its use is generally discouraged in high strength concrete. You see here grading of aggregates. Well graded aggregates is one with the least amount of void in a given volume. Other factors being constant, when total voids are less, excess paste is available to give better lubricating effect. If the grading of aggregate is good, the voids will be less and hence the workability will be more. You see here this represents the well graded aggregates. In well graded aggregates, different sizes of aggregates are available, which fills the voids in between the aggregates. If the voids in between the aggregates are filled, the excess space that would be required to fill those voids will be available for lubrications. In poorly graded aggregates, the voids are more and hence more paste will be required for lubrication of these poorly graded aggregates. Use of admixtures. Admixtures are widely used nowadays in concrete constructions. Use of admixture in concrete is a major factor that affects the workability. We use plasticizers and superplasticizers that increases the workability of concrete by greater amounts. Air entraining agents produces air bubbles which act as roller between particles and they provide better mobility. Thus improves the workability of concrete. Time and temperature. Fresh concrete gets stiffened as the time flows. This is because some of the water used to mix the concrete gets evaporated and some gets absorbed by the aggregates or some gets used in the hydration of cement. Thus the workability of concrete reduces with time. The loss of workability with time is known as slump loss. The effect of temperature on concrete is also noteworthy. As the temperature increases, the workability of the mix reduces.